I can at least, I can give my little spiel real quick, and then Steve, you can give the introduction, and then we'll let Jennifer go ahead and get started. So, so yeah, good afternoon, or I guess good morning for, at least for Jennifer, who is in Mountain Time. So my name is Sarah Grasty. I'm the outreach manager for COMIT, and thank you for joining us for our August webinar. And I hope that we can see you all again. We've got actually 3 more webinars because last month's had to be rescheduled for November. So we still have a pretty solid lineup for the rest of 2022. And I'll link our webpage and newsletter sign up and etc. in the chat in just a second. So for today's presentation, we're going to have plenty of time for discussion afterward, and you can utilize either the chat or raising your hand to participate in that. And as I just said, you're welcome to leave your video on for the duration of the webinar, but just please keep yourself muted until the discussion portion. So now I'm going to hand it over to COMIT's director, Dr. Steve Morowski, so he can introduce our speaker for today, Ms. Jennifer Jencks.
Thank you, Sarah, and welcome everybody, particularly for those who haven't participated in our seminar series before. This is all supported by the Center for Ocean Mapping and Innovative Technologies, which is a cooperative agreement between NOAA and the University of South Florida. Really happy to have today's guest for a variety of reasons. Jennifer Jencks is with the, he's a physical scientist at the NOAA's National Center for Environmental Information. She's also the IHO coordinator and chair of their subcommittee on crowdsourced bathymetry. Jennifer has a BS degree in geological engineering from the University of Mississippi and a master's degree in ocean engineering from URI. And the title of her talk today is Encouraging Innovative Supplementary Data Gathering, the IHO Crowdsourced Bathymetry Initiative. And this is particularly relevant to the program here at COMIT because we are working on a project along with the folks at UNH. And so I think we'll be having our pencils at the sharp and taking a lot of notes here today. So with that, Jennifer, thanks for joining us.
Great. Thanks, Steve, and thanks, Sarah. So it really is an honor to be here. I was really appreciative that Sarah reached out 6 months or so ago asking if I could give a presentation on CSB. I know that there are a handful of you all down at USF that are actually involved in the project yourselves. So this is really great. Thank you. I will go ahead and start sharing my screen. I am going to turn my camera off. I just don't trust bandwidth. And a few weeks ago, I moved out further into the country out here in Colorado. So technology cannot be depended upon these days. So let's see, open share. Okay, Sarah, can you see my screen?
Yes, and yep, it's in presentation mode, looks good.
Okay, great, thank you. Okay, so as Steve said, the title of my talk is Encouraging Innovative Supplementary Data Gathering. It's a pretty big mouthful. So really what I'll be talking about is the IHO Crowdsourced Bathymetry Initiative. I am out here in the Boulder, Colorado area. I work for NOAA's National Centers for Environmental Information. And as Steve said, I wear the hat of director for the IHO's Data Center for Digital Bathymetry, which we host. And I am the current chair for the IHO CSB working group. There are a couple of other folks just looking at the list of attendees today. There are a few more other folks that are members of the working group that are here today, which is fabulous. And I also have my colleague, Georgie Zelenek, who is the Crowdsourced Bathymetry data manager and technical lead of the project out here. So this is just a quick little layout of what I'm hoping to cover over the next half hour. I do want to give just a slide or two about what the DCDB is for those of you that may not be familiar. obviously going to dive into the CSB project, get just slightly technical and talk about how the pilot was stood up 6-7 years ago now. A little bit into, why do we care? What's the value of crowdsourced bathy? How folks are going about collecting and contributing it. Some of those current data contributors, I won't go through all of them. And kind of, where I want to leave it is just kind of proposing to you all the question that we, especially in the working group, have just started to dig into, which is, okay, this is great, but how do we scale? How do we make this even bigger? And then some of the efforts that are currently underway to address that. So again, since I'm going to be referring to the DCDB, since this is where the CSB data is coming into, I really do just want to give a brief explanation of what the Data Center for Digital Bathymetry is. The DCDB is the recognized IHO repository for all ocean bathymetric data. It was stood up over 30 years ago now to ensure that there would be this international repository that would accept and archive and share freely and without restrictions bathy data that is collected and contributed from around the world. It was NOAA's National Geophysical Data Center that stood up the DCDB in 1990, and we have hosted it ever since. And NGDC a handful of years ago did merge with the other NOAA data centers. We're now part of the greater NCEI. So data that come into the DCDB most of the time are not assessed or reviewed, except for maybe just some basic QA/QC checks. And so they reside in our archive as is. The thought has always been that it would remain up to the user to determine the value and the utility of these data for their own purpose. And so even though we do accept processed and products, for the most part, it really is raw bathy data. And so we really look at ourselves as being really the world reference for raw bathymetry data. And of course, these data are routinely used for the production of improved and more comprehensive bathymetric maps and grids to support regional and global mapping projects. So, always in the past, it's been directly supporting JEPCO, and of course, most recently, the focused effort of Seabed 2030. The newest bathymetry data type that has started to feed into the DCDB is, of course, crowdsourced bathymetry. And it was in 2014 that the IHO initiated an effort, a focused effort, to encourage mariners to collect and contribute CSB, recognizing that one, CSB has truly been, collected since the beginning of time, but really recognizing that traditional survey vessels and traditional survey activities alone weren't going to cut it to fill the global data gaps. And so the IHO defines CSB as the collection and sharing of depth measurements from vessels using their standard navigation instruments while they are engaged in routine maritime operations. So, words have meaning. And you can imagine that this was, not a simple definition to come to agreement with, but, an important aspect to really point out is what is CSB not? And CSB is not systematic surveying or marine scientific research. Now, the first step of this initiative was the formation of the working group, the Crowdsourced Bathymetry Working Group. And the main task that was given to that working group was to develop a publication that would state the IHO's policy towards and the best practices for the collection and sharing of crowdsourced bathymetry data. So this document is referred to as B12, the IHO guidance on CSB, and it was first published in 2019 and is available at the URL shown here. The reality was that B12 really hit the streets well before the project really got off the ground. So after a few years of the document being out there, there was enough feedback from actual operational use and experience and a growing desire in the community to make the document more equipment agnostic, that it just made sense for the working group to sit down and to do a top to bottom update. Another intent was to try to simplify the document a bit more, with the hope to making it more accessible to all readers, to collectors and providers and data users. And so edition 3.0 is actually out now. So there's the URL there in its draft form, and it's been put to the IHO member states, I think the 96 of them, for their approval. So for an official vote by the member states. And so we hope to get that approval later this fall. So the working group has been extremely busy. We've met 12 times, obviously virtually, for the last several meetings. We've had one in-person industry day. And I really want to stress that the working group is by far the best way to learn about all the ongoing CSB efforts that are out there. I just kind of want to highlight that pretty long list of observers and expert contributors. We have representatives from, hardware and software companies. We've got a bunch of scientists out there. Couple that with, hydrographic representatives from hydrographic offices, and it makes for an extremely diverse group and lots of engaging conversation. So just want to point out that if you're interested in learning more about the technology, the progress of the ongoing projects, new projects that are coming on board, even if you just have questions or concerns about data collection and sharing, I would consider attending a meeting, and at the very least, visiting the website there and learning more about the great work that's taking place. So that's the working group. In addition to the working group, to support the effort of the CSB initiative, you then had the DCDB, my shop, really focusing their efforts starting several years ago on creating and hosting a data pipeline so that these data would have a place to live. Back in, I think it was 2016, NOAA's Office of the Coast Survey director at that time really saw the value of the initiative and reached out to Rose Point Navigation Systems. Rose Point was really happy to collaborate and to add a new feature to their navigational system software, Coastal Explorer, which would give their customers an option to log GPS and soundings data. From there, the mariner could choose to remain anonymous or capture basic metadata about their boat, about their equipment. And then whenever they would update their software or their chart catalog, then that data would be posted to the DCDB. Coast Survey's research vessel, the Bay Hydro 2, collected over 100,000 soundings over a span of 12 days to test the Coastal Explorer logging capability and the data transferring mechanism to the DCDB. Those early analyses of the aggregated data demonstrated the efficacy of CSB by highlighting trends where the seafloor had likely changed from charted data. So it was a really positive pilot. This is a really simplistic cartoon showing how the data flows in. But what I wanted to point out is the screen grab of what is now a pretty dated log file with its JSON metadata string, just to give you an idea of, what is this data that's coming in. So when this data is posted to the DCDB, they're archived pretty instantaneous, and then made available to the public through our map viewer. So again, a simplistic cartoon here, but it's a pretty simple system. So in a perfect world, after the Rose Point pilot, everyone thought we were really ready to start expanding to other data providers. This is a cartoon from an early draft in our B12 document that shows, okay, we're going to have data collected by all these different boats. That data is going to be sent to a trusted node or a data aggregator, and I'll speak more to that in a minute, and then sent to us. Great, easy peasy. And really the data did begin rolling in pretty quickly, especially from Rose Point. That's what you're seeing here, and especially around US and Canada, who were both very big proponents of this initiative from the beginning. But just as the project was really starting to gain momentum and attention, the IHO really started getting pushback from many countries. And the result of that pushback was an official IHO request to its member states to formally indicate their position on the provision of crowdsourced bathymetry data collected within waters of their national jurisdiction going into the public domain. And to date, there's only been 32 member states, so what the countries you see there in green, that have replied positively. And so what this meant is that we at the DCDB were asked by the IHO to implement a geographic filter into our data ingest pipeline for all of the incoming CSV data that would take into account these national positions. So we did. We implemented a set of topologically correct polygons for each EEZ and territorial sea, where each polygon would be attributed with a flag indicating the restriction, a yes or no. And then further caveats provided by the country would be adhered to. And that's really those three boxes you see on the right. So perhaps they were fine with the data being stored, but only given to JEPCO for SEBA 2030 for the global grid. Complete open access. So yes, please archive it and make the data discoverable and accessible. Or to the countries that said no, or to the countries that haven't replied at all, then if that data was to come in from those waters, it would simply be stored and would not be distributed. This past summer, our developers have begun working on an automated notification and approval system for data collected in these areas of jurisdiction for those coastal states, excuse me, that might have provided a positive response, but in their caveat requested the right to pre-approve the data before it would be distributed publicly. So the vision here, what we're testing with some countries, is that they would be given login credentials, a representative at a hydrographic office that would allow them to log into the system and accept or reject the public release of data from their area of jurisdiction. So you can see the filter working here in the Arabian Sea and the Bay of Bengal, where you can see that the data was cut off at these coastal countries' EEZs. So globally, this means that about half of the data that we've received to date has actually needed to be filtered out. So this data is, potentially useful data, and that's what you see in red, that will not be made available to the hydrographic offices or to the public, to any of these, international or international mapping programs until a country provides a positive response to the IHO's request. So to say that, that was really frustrating would be an understatement, but this is the world we live in, and we certainly respect all nations' positions on this. But again, it was frustrating. We were picking up all this momentum, and then it was certainly slowed down because really what we see is such a potential value of these data, value that really can't be overstated. Like most citizen science, volunteer, and crowdsourcing initiatives, a really big piece of the value of this data is that it comes at little to no cost. It's data that's already, being collected out there. And while the data is oftentimes nowhere near the quality or accuracy of professionally collected data, it does have a role. It can still fill gaps where data might be scarce. It's incredibly useful along coastlines where maybe a survey vessel isn't going to go visit very often, but you might have a fisherman who goes there every single day. And, the data may or may not go into a nautical chart, but it can and it has been used in aiding in the identification of uncharted features and in assisting in verifying charted information. So, bottom line, there really is a role here for it. And in fact, the Canadian Hydrographic Service has been using CSV data to update several of their inside passage charts along coastal routes. They've been using the data for chart comparisons to help prioritize survey areas for the following survey season, and has also been used to initiate the publication of notices to mariners. But policy issues aside, the potential can still only become a reality if we can just get vessels to collect and contribute their depth information while they're on passage. So, transition, how can they collect and contribute this data? So B12 is really the best first step in learning how to collect and contribute CSV data. So this is usually where we point people to first. The document, especially the newer edition, goes into detail on how an organization, a company, a university can become this term trusted node, which is the term the working group came up with to use for a data aggregator. A trusted node can also, they don't have to, but they could supply data logging equipment. They could provide technical support to vessels. They might be the ones actually going out to the boats and downloading the data from a data logger. But ultimately, their key responsibility is to make sure that data transfer happens to the DCDB. Just worth pointing out that these data that are described in detail, the data and metadata, must be provided in either CSV or GeoJSON, and really just capture a very minimum amount of information. We're really just talking XYZ and timestamp. The document does go into more information though about, hey, you want to provide more, we'd love for you to, and here's all the different additional fields that you can certainly provide that rich information if you desire. So we currently have a pretty diverse set of trusted nodes, and it's kind of a blessing and a curse when it comes to the communication of this project, because most folks say, hey, how can I contribute? And there is no one way, right? There's all these different pathways that can be taken for collecting and providing that data. We have software companies, again, in addition to RosePoint, we have Navico CMAP, so another navigation software company that's been really active in the working group, and that just this year has finalized testing of a new bathymetric feed from their customers to the DCDB. And so our hope here is to have that data flowing in later this summer. We also have Farsounder, a hardware company, and Farsounder is another big proponent, big participant in our working group. So their company designs and manufactures 3D forward-looking sonars for navigation and obstacle avoidance. And they have given their customers the option to participate in CSV collection and contribution, and several of their customers have agreed to do so. MacGregor Germany supplies Carnival Cruise Lines with VDRs, with voyage data recorders, and they also provide data. They've actually been providing data now for several years. So VDRs, of course, log depth and other data sets, and are mandated devices for effectively all ships on international voyages. So this is one, especially now that we're coming out of COVID, that we're really hoping to get more of Carnival Cruise Line and more of MacGregor's customers participating in the project. Then last year, we established a feed between the DCDB and PGS seismic vessels, and we are currently working with M2Ocean to finalize their metadata content and to finish up testing their data submissions from data that are collected by hydrovols, which are these small autonomous bathymetric buoys. So this is another contributor we're hoping to have online very soon. And then we have the really amazing work by Dr. Rob Beeman down at James Cook University, which some of you might be aware of this work, because we certainly highlight it at any chance we get. Over the last several years, Dr. Beeman has distributed, gone out there and handed out data loggers to volunteer vessels that use their own echo sounder and GPS sensors along the Great Barrier Reef. And these data, it's kind of the perfect flow. It's data that he uses for his own project of improving DEMs of the Great Barrier Reef. It's data that goes to his hydrographic office and then to the DCDB. So we haven't made this data. We've been sitting on it now for several years, and we'll be making it publicly available over the next several months, as Australia did just submit a positive response to the IHO permission letter. So we're super excited about that. And then last one, most recently, as in just like 2 weeks ago, we onboarded the Great Lakes Observing System. And so their data, not the super best color here, but is actually the data in orange. So that pink data was the Rose Point data we already had. But just in a couple of weeks, it's been pretty cool, the addition of data from data collected using the Orange Force Marine Mussel data logger. So we're excited to see that these contributions really growing. And then about 2 years ago, we started working directly with the Seabed 2030 project. So Seabed 2030 intends to not just, be a big cheerleader of the project and, accelerate CSB activity around the world by providing some designated funding to purchasing data loggers and helping in the installation of them, but also to serve as an actual trusted node to help get to not only set up that data collection, but to also help in the assembly of that data to not just feed the JEPCO grid, but also to make its way to the DCDB. So in return, a potential program that's interested in receiving free data loggers needs to be able to guarantee that they have the staff, to help hand out these loggers, to help in the setup, and then again, to help make sure to work with Seabed 2030 to make sure those data find their home. And Seabed 2030 has been really busy. Impressively so, given the COVID world we've been living in. They've deployed data loggers around the world. They've had, I think, 30 or so make their way to the Greenland Institute of Natural Resources. I think, yes, 100 here that have gone to the Institute for Maritime Technology, who's partnering with the South African Navy Hydrographic Office, and then another 100 data loggers that have made their way down to Palau. Nothing goes as quickly as we hope, but again, the world's climbing out of COVID, and the momentum of these projects is really picking up. And in fact, the U.S. Navy just returned from Palau just a couple of weeks ago, where they assisted in the installation of the first round of data loggers on a handful of vessels, and will be going back out there, I believe, in the fall to install them on another dozen or so. And then finally, for this Seabed 2030 project, it's absolutely worth highlighting the really great work that the New Zealand Research Institute, NOAA, has been leading with handing out data loggers and really assisting just a variety of different communities in their backyard. And that data is just now starting to roll in as well. So 6 years after that initial pilot work, 8 years since the IHO said this is something that we should be focusing our efforts on. Here we are. The data that you see here in pink and blue and purple, which if you go to our viewer, those colors represent the different data providers. So obviously I'm biased, but I do think that this is pretty impressive, that there is so much excitement and involvement from a whole variety of folks out there, from the individual mariner that asks for a data logger because she's sailing down to Antarctica to, industry. And that's really great. But we've got to be honest, At the current rate of onboarding new data providers, of the rate of getting those providers to collect and contribute data, of trying to get nations to change their viewpoint and to agree to allow CSB from their waters to be made available. At all this current rate, we have to ask ourselves, what is the realistic impact of crowdsourced bathymetry on filling these global bathy data gaps? Like, what's it really going to be? And we know as a working group, because this is what we talk about, that there are several, that while these several years have shown that the potential of crowdsourced bathy is there, there are obstacles that are going to need to be overcome if we're going to figure out how to really scale this up. Because a successful crowdsourcing effort needs just that. It needs a crowd. So the obstacles that are currently preventing this from happening are real. And so the focus today, and in the working group moving forward, is going to be to try and not only identify the obstacles out there, and here are a few of them here, but then of course try to strategize on how we can overcome them. So just starting with technology, collecting and contributing CSB data has to become easier. We have to continue to reduce the barriers to entry. And in fact, there are folks out there that are trying to do just that. And Brian Calder, who many of you know, and who's on the call today, has been extremely active in the CSB initiative and in the working group from the beginning. And he's the one that's been, pressuring us for years now, in trying to answer the question, what is the minimum cost and minimal functionality data collection system for CSB, or for VBI, the voluntary bathymetry information, as he refers to it? And his vision, which is now a reality, is that this isn't just about having cheap data loggers to hand out, though that is key. And it's not just about giving them the best name ever, which I think Brian has done in the name of the WIBBLE. But it's also about an entire system, a system that includes all of the software for processing, for formification, and for transmission to the DCDB. So I know that USF already has one of these WIBBLE loggers in a box for testing. And so there are some of you, at least, probably already have even hands-on experience with it. But for the rest, just consider this slide as sort of the highest of high-level introductions, one which Brian would be happy to go into all the levels of detail you may be interested in. Of course, this is a standalone presentation right here. But my biggest takeaway to this system is that everything you see here is open source, and therefore, available to anyone who's interested in collecting their own data. And because the system pushes all of this data to us, to the DCDB by default, then that's a built-in guarantee that the data is going to show up. Not just show up, but show up in the right format, making it easier now, not just for anyone to collect, but also to submit that data to the DCDB on their own behalf. So again, lowering that barrier for collecting and contributing. But as far as technology goes, that's just one piece, right? The other piece is improving the access and the usability of this data. And that's where Georgie and I and our colleagues at the DCDB, that's where we come in, and that's what we're trying to move towards. For starters, we're trying to move all of our bathymetric data, not just CSB, into the cloud to facilitate their use both for on-prem applications as well as cloud-native processing. We've stood up a cloud-hosted scalable point data store to better handle and store the CSB data as a seamless collection of points, in addition to the flat files that we already serve them up as. And that's really been our first step. The thought is that in doing so, bathymetric grids of a given area can be generated, a much more useful product to many folks out there, especially when we're out there gathering user requirements. And these pilot efforts, which to date have just been applied to our CSB data holdings, because those are the smallest and easiest to deal with, are now being expanded to include all of the DCDB's multi-beam data holdings as well. And so just worth pointing out to you all that we have a web application known as AutoGrid that's actually been around for a very long time. But we're now putting resources towards developing an AutoGrid 2.0, which will run in AWS and is going to include both multi-beam and CSB. Eventually, we want to include single beam and possibly our LiDAR collection as well. And the application will eventually allow the customer to produce that custom data grid, show data density, which could help future data collection efforts, and provide statistics on bathy measurements. And again, therefore, improving not only access to these data, but also their usability. But again, improving the technology piece of data collection and contribution and access, again, that is just a piece. We also have to really understand why the majority of coastal countries still have not provided permission to sharing CSV data that's collected in their waters. For many, it does fall to confusion. It does fall to a lack of understanding, not for all, but for many. But a lack of understanding of what is CSV, going back to that definition. What is CSV? What is it not? And so this, of course, falls to outreach and communication, not just from the IHO, but also from the nations out there that are supportive of CSV. And finally, there's perception. It isn't just about encouraging the governments to come on board. It's about explaining to the various communities, why should they participate? Why should a fisherman share his data? What's in it for him? And over the last 2 years, in addition to this big focused effort on updating B12, our working group has also been focusing on developing, community or sector-specific informational flyers in an attempt to highlight the special needs and the special concerns from within each of these groups. These flyers went live at the beginning of this year. Super excited about that. And we're finally beginning to actually have, in-person outreach opportunities to be able to hand these out and to be able to listen to the communities and answer their questions and try to make progress there. So last slide here. So the IHO Crowdsourced Bathymetry Initiative is really just another piece in this massive global effort, to map our ocean floor. But it really does stand to be a pretty big piece. I love this quote from our colleague, Tim Thornton, who crunched these numbers years ago. If we got 1% of all seagoing vessels to log data, and on average, they spent half their time at sea, and that's about 5 billion data points a day. Pretty awesome. But the obstacles, while they're not insignificant, I do think that they can be overcome. And I think with our ever-growing working group, with the ever-growing passion out there, I'm thinking that they will. So with that, thank you for listening, and would love to take any questions.
Yes, thank you so much, Jennifer. Excellent talk, and you've got a very good response on people showing up to this meeting. There's quite a few folks that have a significant amount of experience here, including Brian, who's on board, and of course Georgie is here as well. I have a 1,000 questions to personally I'd like to ask you. Number one, we want to sign up as a trusted node. I think that would be awesome. And I think it fits in with what we want to do. I would note that in Pinellas County, where we sit down, it's a very active private boating community. There are 53,000 registered boats in this county. And so, yeah, I mean, you're talking about your 5 billion data points. And, they're constantly going in and out of inlets. And so this notion of map once, use many times. Well, we can map many times because some of these areas are subject to change, and so this notion of change detection from something like Crowdsourced, where you can do sort of comprehensive maps periodically, but Crowdsourced constantly, I think that would be a really nice application of this, and so anyway, I won't pump that tire too much, but I do get a sense from your talks about the difficulties in getting different countries on board. It's not unlike the satellite data, where there are countries who fly satellites who won't make it generally available, and then of course there are countries like United States and Canada and Australia who fly satellites and make it available to everyone, so it's the same subset of countries, frankly, and for whatever reason they want to keep state secrets, which doesn't help the maritime industry much, but I guess the answer there is you've got a lot of multinational corporations who are not necessarily home based in any of these places that if you worked with them, there might be a way to do that. But anyway, they're just some random thoughts. Certainly invite anybody who's online here to ask you questions. I see Neil Weston is there. So Neil, please ask your question.
Thank you. Nice talk, Jennifer. Could you say a few words about any possible corrections you apply to the data, or how do you determine if there's a bias or offset that's come in? I think those are really challenging, but I'd like to hear your thoughts.
So the easy answer is we don't. So we take the data in as is, and for the most part, just leave it like that. One of the motivators for doing this and rewrite or update of the B12 document is there was a bit of a shift among a lot of people in the working group. At the beginning, it was just, we want uncorrected data. That's it, nothing more. Not everyone agreed with that. I'm sure Brian Calder is shaking his head. He was not a proponent of that. And over time, we've had more and more data contributors, such as Dr. Rob Beeman down at James Cook. That's like, I'm wanting to, I don't want to just send crap data. I want it to be good data. I want to, apply corrections. And so a lot of the changes in B12 have been to the metadata, have been to the ability to now provide all different levels of processing. Because again, that lowering that bar, we don't want to leave anybody out. Anyone who wants to participate and contribute can. So now we just encourage, whatever corrections are applied, please have it captured, make sure it's in the metadata. But it's still, that work is still on the provider. It's still just, it's not anything that we as the data center are participating in.
I think down the road, you may be able to do, given the fact that you have the lat long of each observation, you can watch that, if you will, do a running average and see if there are any outliers. So over time, you can build up confidence. Yes, we think these measurements are very good. But for data collected in a less traveled area, you have to start somewhere. But yeah, thank you.
Right. Well, and it's been nice chairing the working group these past 2 years because we've had this very focused effort of, improving B12. That's what we're doing. But I'm excited to be moving away from that because there's so many different areas that we can be exploring. We haven't really had those conversations about that. We haven't really, other than the Canadian Hydrographic Service, who active participants in the working group, but they have really focused on trying to develop processes of trying to analyze the data and all that. We're hoping now to have others in the working group do just that and to start looking at these different areas. And I think I did actually just get a ping from Brian. Brian, do you want to add to that? And a lot of the work that you all have been up to as well?
Sure. Yeah. I don't want to rain on your parade, but
No.
Yeah, so estimating corrections, you can do it. It's not trivial to do because most of the data currently there doesn't have very good metadata. The more we get, the better it is. But we did publish a paper recently on observer reputation, and also one more recently than that on data reputation, where we attempt to estimate how much we can rely on any individual observer. And quite interestingly, it uses a mechanism that's used primarily for ranking chess players and the strength of chess players. So we modified that to give us a score for each observer, how good we think they are, and we can use that for things like, answering the question of how many observations of a discrepancy from any individual observer would I need to convince myself that there really was a discrepancy there. So there are mechanisms being developed for things like this. Getting enough data to feed them has always been the problem, which is why trying to get to scale is one of the bigger issues here, which is, the goal of the project that Jen was kind enough to mention, the WIBBLE project, where we're trying to get it set up so we can encourage as many people as possible to be able to contribute their own data.
Sarah, I see you have your hands up.
Yeah, thank you, Jennifer. So my question might be a little bit out of the box, but I'm curious if some of the responses from coastal countries that have not decided to opt in have come from sort of feeling like it's an extractive thing from maybe wealthier countries who can afford to do stuff like this, and who are just generally, I guess, just wealthier countries that are kind of coming in, and it's a feeling of it being sort of extractive. If that has come up at all, and if so, how you all have talked about that. And then the second part of the question is also talking about incentivizing participation. Now, you mentioned the greater accessibility and making it easier to flow into the pipeline, which is all well and good, but are there other incentivization efforts that you all have discussed?
Those are great questions. So the first one, so that actually hasn't been a response that I'm aware of from coastal countries. There is online, the IHO did publish sort of a summary. They certainly didn't say country X feels this way, but they did sort of summarize some of the general feelings, why some countries were not supportive. And so that wasn't one. A lot of the takeaway was different interpretations of UNCLOS, of the law of the sea, in which the IHO knows that they need to continue to do a better job engaging and just having conversations about that. But really, it was actually quite a lot of countries that just responded that they didn't see a need for it, and I think that still falls under outreach. Just what Steve was saying, some would be like, we will never apply this to our nautical chart, so we don't want it. And going like, that's great. That's obviously that's your prerogative. However, that's not the only use for these data. Look at all of these other uses. So there's that piece that still needs to take place, but I am confident we can overcome some of that. Again, as always, there will be countries that just aren't going to sign on, and that's just the end of that. But the incentivizing, that is such a huge piece. And I think I mentioned talking about the working group that we held an industry day in 2019. It was our last meeting before the world shut down. And that was a huge piece of that conversation with industry, was we do need to come up with a better way to encourage people and convince them to sign on. I know Brian, and I'm not going to put him back on the spot again, but I do know that Brian did, and one or two of his students a handful of years ago actually did a really big survey of, right, what would it take? What is it that you want that would get you to want to participate in this? And oddly enough, or surprisingly for me, at the end of the day, it really was, they want the data. It really is, that is what most people are the most interested in, is like, yeah, I'll collect it, but I want it. I want this data. I want others' data. And then for us, then Brian would then look at us and be like, you got to do something with this data to make, you know, can't just be a PhD student that has, you know, that can access it. We need to make it available and usable for all. So that has been our focus, is listening to that feedback that Brian and his students received, and trying to put the focus on that.
Yeah, it's interesting because I know that you know, as far as the multi-beam surfaces that are available, there are companies that have monetized that by making it available for chart plotters. And you know, if you're talking about getting into the kind of more private everyday person who might be going out on their own boat, trying to then somehow, you know, get it back to them in a usable format, which for them would be their plotters that are on their boats, not necessarily sitting on a desktop looking at a, you know, a portal or something like that. That's sort of might be an interesting thing to look into, but not to take away from capitalism, but, you know.
Exactly.
You know, looking at these issues, I think they kind of bifurcate a little bit in terms of the interest. There's a sort of private, you know, recreational boaters who, you know, are a potential huge audience here. Both they're interested in providing, and they take benefit. But then there's the commercial mariners, right? And you know, their worst day is something like Costa Concordia, right, where they bump into something that wasn't charted. And so I would imagine that the professional mariners would like to have something when there's nothing, right? And that's got to be a huge motivation from their point of view. So I was thinking a little bit, Jennifer, about, you know, the global map that you showed, and you know, you've got, you know, all the crowdsourced bathymetry coming in primarily from coastal areas, and you pointed out how much of the map wasn't developed, and I'm wondering if there's an experiment there where there's a lot of interest in satellite-based bathymetry now, right? So you could use ISAT and Sentinel and those things to get a bathymetry for even for some of these countries where they're not necessarily you know, going to provide the ground truth, but that you could overlay, you know, satellite bathymetry with the crowdsourced and maybe come up with some kind of a, you know, calibration coefficient, you know, that you know, it would be an interesting, that would be a great dissertation, you know, in terms of a student to see just, you know, how well they comport. And of course, you've got some areas that have been multi-beamed by a government agency, for example, and so you have this all calibrated, you know, that's the trifecta, you know, of calibrations, right?
Well, you got a lot of smart students that are tuning in today.
Yes, we do.
They're throwing out project
I'm
ideas.
casting a fly out there, right? But you know, I mean, you know, so much of those data have already been collected, you know, by the government, particularly in terms of satellite data, and we're finding that our own work here that the satellite bathymetry is surprisingly accurate given the sort of announced precision of some of these satellite systems, right? And so if that's the case, then, you know, perhaps that opens up the synopticity of all of this, right? So apparently we got Brian's dander up here. So Brian.
No, not at all, not at all, Steve. Just wanted to add on to that point, actually, which is to mention that there is a second class of, or not, I don't mean second class, I mean a different type of volunteer systems, which are designed to be self-calibrating, and there's a couple of different ones out there that we can point at. And you have. We sent you one for you guys to play with, and there's another ones that are built from, for example, at CIDCO, the Hydroball and Hydrobox that Jen mentioned in her presentation. And the difference with these, and I know you know, but maybe participants on the call don't, but the difference with these ones is that they have inbuilt a better GNSS receiver so that they can, in post-processing, typically resolve depths to the ellipsoid with an accuracy on the order of 5 to 10 centimeters. So another option for calibration is you have a whole bunch of cheaper data collectors collecting volume data, and one or two of these self-calibrating systems that can provide the calibration. And then you can do it in areas if you don't have SDB or if you don't have authoritative data and so on. So there are lots of really good opportunities out there to do these sorts of things and to strap rocket engines onto a data collection effort.
Yeah, that, you know, those points I think are really important, Brian, that you don't need many, you know, sort of authoritative observations in order to be able to, for example, each vessel probably has a characteristic offset because of where the transducers are placed. And so, you know, if you can estimate those by sort of, you know, proximity, right, then now you basically have the key to the whole thing.
Yeah, not to self-promote too badly, but we actually published a paper on that recently, and so there, you know, you can actually do that. The interesting thing, though, that we found is that they vary. There are ships that will change their offset. Yeah, there's one particular ship that we looked at, for just by way of example, in the Seattle area, where it changed its offset by a significant amount, and the best guess we have is that they loaded up for a long voyage. So they, you know, pressed tanks full, put on a bunch of stores, and put on a dinghy, went off for 4 months, and their offsets changed, and then came back and unloaded the dinghy, and it went back to being normal again.
Right.
So these sorts of things happen, but it's a dynamic process, which makes it, of course, a much more interesting problem to work with.
For sure. Yeah. Other questions, observations for Jennifer?
Hello?
Yeah.
Yeah, this is Tony Gilbert from the International Seakeeper Society, and we've actually recently partnered up with Seabed 2030, and you know, they've supplied us with a number of loggers, and we've used our network and just, you know, our yacht network to distribute these. And so we've had a few takers, more than a few, and we're trying to get that number to go up, of course. But one question, the more and more I go out and pedal these things around, and one question I get is, my transducer isn't that powerful. It probably won't read anything beyond about 1,000 feet or 2,000 feet, or, you know, something in that ballpark. So what good is that if, you know, I can't even read depths that are all that deep? You know, I've had answers where I say, hey, look, you know, we understand, and it's generally understood that, you know, if you don't have these multi-beam, you know, research vessel type equipment, that's okay. Something is better than nothing. You're still contributing in the more kind of coastal, closer to offshore regions. But yeah, I mean, what's the official, I guess, statement on, you know, if we're putting them on more like everyday leisure vessels, and they want to know what good they can do if their transducer isn't that powerful.
I mean, I feel like you're doing.
I feel like you're doing.
You're doing a good job.
You're doing a good job. Okay.
Tony, if you
all
could,
right.
Tony, if you.
Yeah, sorry. Go ahead.
It must be your echo.
It must be your echo.
There we go. I was just going to say, Tony, and first of all, I'm glad that you mentioned that about international seakeepers. I am envisioning having a new slide here in the next few months, because I know that we've started to look at that data, and we're excited to get that data in as well. But I think that your answer is correct. I mean, yes, for most people, this is going to be pretty near shore, but also what Steve even referred to, the near shore is where everything is changing. It's data that can be used for all sorts of different sorts of change analyses, and still in many places there just isn't that much data, even if it is highly trafficked. You know, we have a colleague on the working group that constantly talks about Monaco. He's like, we have all the money here, and yet he's like, I know that super yachts that are going back and forth over areas that there are no soundings on a chart. So I would say that there's still an extremely invaluable contribution that these folks are making. But that also goes back to outreach and our job to our need to do a better job in getting that messaging out there. But I did just look at the time, so I will hand that mic back to Steve and Sarah.
Yeah, thank you, Tony, for that question, and thank you for Seakeepers being involved in this. I think that's an important aspect. I actually wanted to ask you one more question before we leave, and that is, you mentioned fishing boats, and I know from my long history of working with fishing boats that they're okay when they're coming into port and going out of port and maybe cruising around, but when you're on their hotspots, they do not want people to basically mind that hotspots. So is there a way that a boat could self-censor, the positions that go in there, easily, not, sort of, take the data stream and play with it for a half a day? You're muted there.
Thank you. That's a really good question, and that is the button issue there with fishermen, of course. But it would depend, right? For all of those that are using Olex or using Rose Point or something like that, I mean, I would assume that the simple response would be just turn off logging. Once you've got to your spot, turn it off. But can you please turn it on when you're going to and from,
Right.
or when you are having a nice little Sunday afternoon where you're not fishing? I think what we have found has been the issue. All of these different issues, it comes down to so many people's interpretation is just black and white, and that we're really trying to find that area of gray that allows for participation. And again, this is even the countries as well, right? It doesn't have to be black or white. Here's a new capability that you can look at the data first, if that'll make you happy, But that would be the conversation I would want to have with the fishing community. Is there ever a circumstance where you would be comfortable in recording data? Okay, can we just start there?
Gotcha.
So
that's an opportunity for sure. Well, we have run out of our time, as I knew we would, having a discussion on this, a really topical point right now, and one of extreme interest globally and certainly nationally as well. And I want to thank our audience, which actually grew substantially during your talk, and certainly thank you, Jennifer, for a great talk and inspiration, frankly. And if there's anything that we can do for you all, please don't be a stranger to our seminar series.
sounds good.
So
thank you both again.
Have a little clap for you. Virtual claps are harder than real ones, but nevertheless, great talk. And I would like to announce our next seminar. It will be Rachel Gitman. She's at East Carolina University, and she'll be talking about coastal processes, particularly as it relates to coastal change. Really important topic, and one that interfaces, frankly, with this one as well. So thank you all very much for participating. I hope you learned something. I certainly did. And thank you to our speaker, Jennifer.
Thank you, everybody. This will be on our YouTube page by the end of the week if you want to send it to any of your colleagues or recap what you saw here. So
great.
All right. Thank you all.
Thank you.
Take care, everybody.
Thanks, everybody. Bye.